Hey guys, welcome back to another episode of Just Fixing Stuff. On this episode here, I'm going to just go over the basics of how a pressure switch works. And more or less, they're a pretty straightforward thing. It's quite ingenious when you think about it, but basically it'll consist of a switch that on one side is the common, and then on, as you can see right here, there's a normally closed and a normally open. There can actually be multiple versions of this depending on what kind of pressure switch you have, but we'll just stick with the basics for now. This one here has a common, normally closed, and a normally open. And then it also has a positive side, and then if you flip it over, it'll have a negative side, if you can see that little negative sign. There'll be some kind of indicator as to which side is negative and which side is positive. Almost always. This one here happens to be a universal pressure switch, so it does not have the pressure posted on here, but typically if you run into one of these out in the field, they will have the make, model, or the part number, and then they'll also have the pressure of that pressure switch, whatever it is set at, in typically inches water column. And basically that's just a way that you can, if you can't get the exact one from the manufacturer, which you always want to try to get if you can, but in a pinch you can always match up the specs of that pressure switch. So you'd have this one here, which has a normally closed, a normally open, and a common, and then you'd have a positive side and a negative side. Some of them only have one or the other, so like a positive pressure or a negative pressure. For these things here, whenever you, let's say, for example, on this one, because it's universal, it actually has the ability to remove this Allen key little nut or adjustment screw. Take out the adjustment screw, and then it comes with a series, or a variety, I should say, of different springs. And based off which spring that you pick, it's ranging from 0.1 inches water column all the way up to, I think if you use the blue one, it's 10 inches water column, or 5 to 10 inches water column. So each one of those will have a range of how far they go. And then also, just for the actual, to create enough pressure in the system, they also have these little orifices that you can, if you're, for example, if you have it set at a certain amount and you can't get quite the exact pressure from these springs, then you can add these orifices that will allow for the proper airflow, or the proper amount of pressure needed. And you would just take one of these and insert it inside here. I'll show you. So you take one of these, and on this side you insert that there, and then you would just push down, and now you have narrowed this hole so that it can be the proper amount of pressure going into this hole, in and out of there. And a lot of times they'll do this just so that it has a much more consistent pressure on this pressure switch. But the way that it works, to break it down simply, is that on here there'll be a specific amount of pressure from one of these springs that you put in here. Let's just throw one in just for the sake of it. Let's say we'll pick one of these guys, if it's going to cooperate. Yeah. So we're going to say we're going to pick this silver one. And offhand, I don't remember exactly what the silver one is, but we're just going to say this one's 0.5. Okay, so from here, we're going to take that, and we're going to put this adjustment screw back in here. And we're just going to tighten that down. And there is, typically these will come with instructions, and it'll have the method in which you start off by having the switch in the normally open position, and then you would screw this down and adjust it to the point where it'll become the normally closed position. And the reason that you want to do that is because normally closed means that is when power is running through from either the common to the normally closed, or the normally closed typically will be into the common. So generally you would want to have the power coming through. It connects onto the normally closed, or depending on the style of switch, some of them will have it on the normally open. And then from there, when you have normally open, power's being applied, but because the switch is over on the normally closed side, there has to be enough air pressure coming through here. On this side, it'll have to be positive air pressure coming through here in order to push this. There's a diaphragm in here, kind of like a rubber balloon, if you could imagine that, and it will make or break this switch, and it'll push it from the normally closed side over to the normally open side, or vice versa, depending on the switch's arrangement. But essentially, it is applying air pressure to here to move an electrical switch one way or the other, making or breaking the electrical connection, and whichever one that it does will obviously impact whatever your system is running off of. So this one happens to be for a furnace. So usually it'll be what's called an inducer motor will be hooked up, and the inducer motor is the first part of the sequence. It'll start running, and when there is enough positive and negative pressure from that inducer motor and from usually what's called a condensate or some kind of exhaust system, it will be able to go from this normally closed position, and now that there's power being applied on this normally open position, when this pressure reaches a certain pressure, whichever you've specified on here, this connection will come over, and then it will complete a circuit in that furnace. And so it'll basically, it's kind of like a safety mechanism. It actually is exactly a safety mechanism. And it's just so that it knows that if you have an inducer motor running, they want to prove that the inducer motor is running at full capacity, so that, because the job of the inducer motor is to induce, or for lack of a better term, evacuate the exhaust from your system. So then it's taking all the carcinogens or any kind of exhaust and pushing it out from, pulling it from the combustion chamber and pushing it pushing it out into wherever it has to go. So whether that be outside or into some kind of containment unit or something like that. But in order for that to happen, it wants to make sure that that inducer motor is running at peak efficiency. Otherwise, it just won't allow the furnace or whatever you're working on to get to the next step in the order of operations of that system. That's pretty much all there is to it. The big thing is, this one here is a little more complicated, only because it is a universal one. So there's quite a few options with this universal one. In all reality, you're not going to encounter this too much. This one here, unless you're a gas fitter or you work on furnaces or controls often, I probably wouldn't even entertain this one, because you'll have to use what's called a manometer, or it's basically something that reads air pressure or pressure in general. So you'd hook up a gauge to one of these things, the actual ports on here, and you'd have a T that splits from the system one half will go to this pressure switch, and the other half will go to your gauge or the manometer, and it'll be able to read what kind of pressures that the system is drawing in order to make this be able to make the connection. And then you would adjust this spring according to how much pressure that was required in order to safely make the inducer motor go to the next stage. But you will get that pressure from the manufacturer. Again, this one here, typically when you see an old school furnace, like something probably post 80s, but early, maybe up to early 2000s, usually you'll only see just the pressure, the positive pressure side. And it's just because all they cared about, it'll be one or the other, positive pressure side or the negative pressure side. All they really cared was that it was running and it was actually functioning. Now they're getting a little bit more specific with it, and they want it to run at a specific RPM, or they want to have it at a specific amount of pressure so that they can remove exhaust at peak efficiency. But yeah, other than that, it's a pretty straightforward thing. These are very commonly used throughout control systems. And but yeah, other than that, there's not much to it. If you can like and subscribe and leave a comment in the comment section, that's pretty much all I got. So until next time, thanks for watching.